Hi everyone, I am Dr. K. Kritika, Associate Professor, Department of Mathematics, K.S.Rangasamy College of Technology. I am going to explain about basic statistics. In this basic statistics, the first chapter is measures of central tendency or measures of averages. Under this, there are three types of averages: mean, median, mode. So in each and every topic, mean, median, mode, we are going to discuss three types of data: individual data, discrete data, and continuous data. The first one is individual data. So first, the mean for individual data. So here the example, here we are going to see the example. Find the mean of the following set of observations. So this is the discrete data. So how to find the mean? It means, so if we consider the given data as x, mean for individual data is x bar is equal to summation x by n. So n means number of data. So here the number of data is 10. Summation x means here we add all the x values. So answer is 296 by 10 is equal to 29.6. So this is on example sum. The next one is type 2. It is a discrete frequency distribution. So how to find the mean for discrete frequency distribution? The formula is x bar is equal to summation fx by summation f or summation fx by capital N. So we can write capital N or summation f. Both are same. X bar is equal to summation fx by summation f. Answer is 524 by 40 is equal to 13.1. So the mean for discrete distribution is 13.1. So this is another example. So now we move to continuous frequency distribution. The same mean x bar for continuous frequency distribution is a plus summation fd by summation f into c. So here one example is given for continuous frequency distribution. So here also two data are given. One is height in inches, 50 to 60, 60 to 70. Actually it is called the true class limit, 50 to 60. Another starts from the 60, same 60. So here also it is called the true class limit. And the corresponding frequency is also given. So solution. So in the first column we write the true class limit. Then in the third column we write a frequency. In between first and third one we are going to find the midpoint of this class limit. So 50 to 60, the midpoint of this one is, that means 50 plus 60 by 2 is 55, 60 plus 70 by 2 is 65. So similarly we find all the midpoints of this class limit. Okay. Then after that, before we enter into the fourth column, we are going to mark capital A. So that capital A, find it from the midpoint of X. So here there are 5 datas. This capital A is nothing but the middle of this capital X. So here the middle of X value is 75. So we denote it as capital A. And so X is this. Capital A is also we marked. So what about the C? So C is the length of the interval. So here the length of the interval is 60 minus 50 is 10. Similarly 70 minus 60 is same. So the length is same for all these class limits. So here we substitute. So x means, so how to find this minus 2? It means x value is 55 minus 75 by 10 minus 2. So similarly we find this d value for all these datas. Then after that final column is f into d. Just simply we multiplying. Then we find summation fd. So x bar is equal to capital A plus summation ft by ft into summation f into c. The answer is 77.573. So this problem is another problem example. Okay. So now we move into the second averages median. So what is median? This is a median definition. Median is the value of the middlemost item when all the items are in the order of magnitude. So first we are going to discuss individual data. So how to find median for individual data? So individual data means immediately we arrange the given data either in ascending order or descending order. Then we find the middle position, that is the median value. So now we are going to see this example. Find the median of the set of observation. Actually this is the individual data. So first the observations are in ascending order. Here first we write the given data. This is the individual data. So immediately before we finding a median, we arrange the given data in a ascending order. So the number of data after arranging, we find the number of observations. It means number of data. So here the number of data is 9. So since it is an odd, so easily we can find the middle position. So here 27 is at the middle position. Therefore the median value for this individual data is 27. First, we write X data. In the second column, we write F data. In the third column, we find cumulative frequency. How to find cumulative frequency? In the first column, X data. Second column, frequency data. Cumulative frequency means in the first position of the cumulative frequency is nothing but the first value of the frequency. In the second value means the previous 7 plus 2 is 12 plus is 19. This 19 plus 37 is 56. This 56 plus 25 is 81. This 81 plus 22 is 103. This 103 plus 11 is 114. So this is the procedure to finding cumulative frequency. The last column of the cumulative frequency is nothing but the summation f values. So the formula is n plus 1 by 2th observation, 114 plus 1 by 2th observation. So here 57.5. So observation, 57.5th observation. So now we are going to mark this 57.5 in a cumulative frequency distribution. This 57.5 is lies between 56 and 81. So we underline this 81 upper term. There is a maximum value 81. So here the corresponding x value is called the median of the discrete frequency distribution. Here another example is given. The third distribution is continuous frequency distribution. So median for continuous frequency distribution is median is equal to L plus n by 2 minus m by f into c, where L is a lower limit, n is summation f, m is the cumulative frequency of the pre-median class, f is the frequency, and c is the class interval. This 320.5 is lies between this and this. So now we mark the maximum point. Here the corresponding interval is called the median class interval. So 10 to 15 is called the median class interval. So in this median class interval, this is the lower limit. The corresponding frequency is called the f. This 224 is called the cumulative frequency of the pre-median class interval. Here we see this 10 to 15. So L is a lower limit, N is this, M is 224 and etc. Substitute all these in this formula and getting 12.15. So now we move into mode. This is a mode means, as a simple definition is, it is a maximum repeated number. Mode is the value which has the greatest frequency density. It is denoted by Z. So now we are going to discuss about individual data for finding mode. Mode is defined to be the value which occurs most often. So here two problems are here. Find the mode for the following data. The first data is you write the data. Here we don't need to arrange in either in ascending order, descending order. That is only for finding median individual data. So here we are going to find each and every data occurs how many times, repeat how many times. So here this 320 repeated one time, 395 repeated three times, 342 repeated one time. So here the maximum number of repetition value is 395. So the mode is 395. So that is called the nature of this mode is called the unimodal. Now we move into the second problem. Again you write the same data. Here 0 occurs one time and 2 occurs one time and 5 occurs 4 times, 6 occurs 4 times, 9 occurs one time and 5 occurs 3 times and etc. So from this what we observe, this 5 and 6 occurs the maximum number of repetitions, that is 4 times. So the mode is 5 and 6. So we are having two modes. So it is called the bimodal. So now we move into the continuous frequency distribution. The formula is mode. That means its notation is Z is equal to L plus F1 minus F0 by 2F1 minus F0 plus F2 into C, where L is the lower limit, F1 is the frequency of the model class. In a median continuous distribution, we find a median class. In the same way here, we are going to find the model class. So F0 is a pre-model class. F2 is the frequency of the post-model class. Class interval C is nothing but the class interval. So here one example is given. Find the mode of the following frequency distribution. So here one class limit is given and frequency is given. So here one difference is here 46 to 50. The another limit starts from 51 to 55. So it is not a true class limit. So before we start the problem, first we are going to convert this class limit to a true class limit. How to find the true class limit? The difference between 51 and 50 is 1. Then we divide that 1 by 2 is 0.5. So now we subtract the 0.5 from the lower limit and we add to the upper limit. So here this is the highest. So just we bold into the bold this 11. The corresponding true class limit is what? 70.5 to 75.5. This is the model class interval. The lower limit this is denoted by L. The corresponding frequency is denoted by F1. The previous is F0. After this F1 frequency is F2. This is pre-model class. This is the post-model class. This is the frequency of the model class. We substitute all these values in this Z. We're getting 72.17. So this is one example of mean, median, mode for the continuous distribution problems. Hope everyone understand mean, median and mode for three types of data. Thank you.